Transformer. A transformer is a static electrical device that transfers AC electrical power from one circuit to the other circuit at the constant frequency. Transformer works on the principle of Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction: the magnitude of voltage is directly proportional to the rate of change of flux. Transformer working is based on mutual induction. Mutual induction, changes in the current of one coil, induces EMF in the other coil. In the figure, you can see current is passing through the primary winding, due to which a magnetic field is produced between primary and secondary coil. This magnetic field produces flux in the secondary coil. The most common function of transformer is to increase or decrease the voltage. Step-up transformer. The transformer which increases, step up, the voltage is called step-up transformer. Or, a transformer that increases voltage between the primary to secondary winding is defined as a step-up transformer. From the figure, note that we are giving voltages to primary winding and we are getting output from secondary winding. Also, for step-up transformer, we have more windings in the secondary coil as compared to primary coil. Step-down transformer. The transformer which decreases, step down the voltage is called step-down transformer. Or, a transformer that decreases voltage between the primary to secondary winding is defined as a step-down transformer. From the figure, note that we are giving voltages to primary winding and we are getting output from secondary winding. Also, for step-down transformer, we have more windings in the primary coil as compared to secondary coil. Why transformer is needed? Normally, electrical power is generated at 11 kV. During the transmission of this 11 kV to long-distance distribution station, losses may occur. So, we couldn't get the required voltages. In order to overcome this issue, we use step-up transformer at the generating station and converts 11 kV to 220 kV or 440 kV. So, when these voltages reaches at the distribution station, they may have a value of less than 220 kV but it is still greater than 11 kV. So we use step-down transformer at the distribution station to convert it back to 11 kV. By this way, we can get the required 11 kV. Transformer parts and construction. The three main parts of a transformer are as follow. Primary winding of transformer. Magnetic core of transformer. Secondary winding of transformer. Primary winding of transformer. Primary winding of transformer produces magnetic flux when it is connected to electrical source. Magnetic core of transformer. The magnetic flux produced by the primary winding, that will pass through this low reluctance path linked with secondary winding and create a closed magnetic circuit. Secondary winding of transformer. The flux, produced by primary winding, passes through the core, will link with the secondary winding. This winding also wounds on the same core and gives the desired output of the transformer. Construction of a transformer. Transformer consists of magnetic circuit, consisting of core, limbs, yoke, and damping structure. Electrical circuit, consisting of primary and secondary windings. Dielectric circuit, consisting of insulations in different forms and used at different places. Tanks and accessories, conservator, breather, bushings, cooling tubes, etc. Working of a transformer. From the figure, note that current is firstly flowing in the primary winding, which is producing magnetic field in between primary and secondary coil. This magnetic field produces electric flux in the secondary winding, due to which current is producing and flowing in the secondary winding. Types of transformer. On the basis of service. Power transformer, distribution transformer, instrument transformer. Instrumentation transformer are further classified into following types: current transformer, potential transformer, autotransformer. On the basis of cooling. Air natural or self-air cooled or dry type. Air force D or air blast type. Oil natural air natural. Oil natural air forced. Oil forced air forced. Oil natural water forced. Oil forced water forced. Power transformer. A power transformer is a passive electromagnetic device that transfers energy from one circuit to another circuit by means of inductive coupling. Power transformers differ from other transformer types in that they are designed to comply with regulatory requirements for mains power interfacing, working at mains voltages and relatively high currents. The most important specification of a power transformer is its primary to secondary transformer galvanic isolation, which is usually specified in kV. This is a fundamental safety aspect in protecting humans from potentially lethal earth fault conditions. Distribution transformer. Distribution transformer or step-down transformer is an electrical isolation transformer which convert high-voltage electricity to lower voltage levels acceptable for use in cities. Instrument transformer. Instrument transformers are the transformers that are used with protective relays for protection of power system. Instrument transformers are used in AC system for measurement of electrical quantities, that is voltage, current, power, energy, power factor, frequency. Basic purpose of instrument transformers is to step down the AC system voltage and current by using potential and current transformer. Current transformer. Current transformers are generally used to measure currents of high magnitude. These transformers step down the current to be measured, so that it can be measured with a normal range ammeter. Current transformer step up or increases the voltages while stepping down or decreasing the current. Current transformer are always connected in series. Potential transformer. Potential transformers step down the high voltage to a lower voltage which can be measured with standard measuring instrument. These transformers have large number of primary turns and smaller number of secondary turns. A potential transformer is typically expressed in primary to secondary voltage ratio. Potential transformer is attached in parallel with the circuit. Autotransformer. An autotransformer is a transformer having only one winding wound on a laminated core. An autotransformer works as a voltage regulator. In an autotransformer, a single winding is used as primary winding as well as secondary winding. Advantages of autotransformer: less costly, better regulation, low losses as compared to ordinary two-winding transformer of the same rating. Transformer losses. Following are the losses that occur in transformer: core or iron losses, hysteresis losses, stray losses, eddy current losses, copper losses. Core or iron losses. Iron losses are caused by the alternating flux in the core of the transformer. As this loss occurs in the core, it is also known as core loss. Iron loss is further divided into hysteresis and eddy current loss. Hysteresis losses. The core of the transformer is subjected to an alternating magnetizing force, and for each cycle of EMF, a hysteresis loop is traced out. Power is dissipated in the form of heat known as hysteresis loss. Eddy current loss. When the primary of a transformer is energized by an alternating current source, a fluctuating magnetic field is produced. This magnetic field cuts the conducting core material and induces a voltage into it. The induced voltage causes random currents to flow through the core, which dissipates power in the form of heat. This random current, called as eddy current, produces losses which are called as eddy current losses. Copper losses. Copper losses occur due to the presence of resistance in the winding. These losses are also called as ohmic losses. These losses are also called as variable losses because these losses varies with the load. Stray loss. These losses occur due to the presence of a leakage field. These losses are very small and can be neglected. Transformer equation. To find the secondary or primary voltage, we use the following equation, where E1 equals primary voltage, E2 equals secondary voltage, N1 equals primary turns, N2 equals secondary turns. Efficiency of the transformer. Transformer efficiency is defined as the ratio of the output power to the input power and is expressed by the following equation.